Sorry guys, apologies. Give me 2 seconds, I'll get my screen back up. I hate technology sometimes. Share screen. Problem with my Wi-Fi kicks me out of my iPad, which is really annoying. I give up. I'll blame Corona. Come on. Right, here we go. Right, back to it. Okay, so hopefully you sort of took that. So there's lots of different ways. Record. I'm recording. Happy days. Okay, lots of different ways we can write that out. Okay, so just be comfortable with that. Okay, so when you see something like that, and we'll do lots of examples over time, okay, in past papers, etc. It's a really common one to get wrong. You just don't get the terms in the right order, which means when we move it to the other side, it becomes a wee bit sort of misjudged and throws you off a wee bit. Okay. Don't worry at this stage, it's just that sort of practice thing. Okay, so another wee example of that, if we had something, okay, if we put a term on the top there, 2x. Okay, we could also write that as okay, and we could even go to the extent of breaking that bracket in the top. Okay, so we get 4x plus 26 over 3. Okay, and then simplify that down. Okay, so just be aware there's lots of wee things. Okay, so that was one of the questions that came up during the Christmas period, but it's a good one because it leads into where we want to be as well. Okay, so let's do a wee example of that. If anyone's still copying that. Okay, so if we do an example and we put that into an equation and we get asked to solve for x, okay, so or solve for a letter. Okay, so if we get something very, very simple, okay, x over 5 equals badly drawn 6. Okay, we know when we're moving that 5 across, we can solve for x, okay, and it'd just be 6 multiplied by 5. Okay, so let's just do that. Okay, so x equals 30. Okay, that could be written as 1/5 of x. Okay, equals 6, and the same sort of rules apply. Okay, so you could see it in both ways now. Probably more common if it was 2/5 x, okay, equals 6 or something along those lines. Just be aware it could be written like that. Okay, so let's do a complicated one. Okay, so if you have something along that line, okay, 4x plus 5 over 2 equals 10. Okay, and you get asked to solve for x. Okay, so remember, there's no bracket there in that top expression. Okay, but another way to write that out, okay, another way to write that out would be half 4x plus 5 equals 10. Okay, put a bracket in front of that. Okay, so when we're rearranging fractions, okay, we need to get rid of that divide, okay, before we deal with that expression on the top. Okay, and that's really, really important. Okay, so I've been harping on about this BODMAS and doing it in reverse. Okay, that doesn't mean we can, first step that we would take would be take that plus 5 across. Okay, we need to deal with that because that whole expression on the top line there, okay, is being divided by 2. We need to deal with that part first and move that across. Okay, so it's just wee intricate parts that we're getting into now, okay, that we just need to be careful of. So you need to be aware that that expression on the top of that division has to stay whole, okay. So it might not be given to you, okay, but you can even put a bracket around that and just sort of have it in your mind that that can be moved across. Okay, so let's just work through that then, okay. Have a wee look at what I mean. Okay, so we've got that written out like that. That expression at the top has to stay whole. Okay, so the first part that we need to move is that 2 at the bottom. So that expression stays whole, and that 10 becomes multiplied by 2. Okay. Okay, and then you've got an expression where I'm a wee bit more familiar with that format of it. Okay, and then we do move that plus 5 across now. Okay, we can get rid of that. Okay, 4x 20 minus 5. Okay, not a very nice one, but that's what it is. Okay. Now, how else could you write this out? Okay, just to give a wee bit more understanding. Okay, we could break that bracket. Okay, so if it's given like that, we could break that bracket down. Okay, and put it down. Just make sure you keep this in separate columns when you're writing this. Okay, but we could write that as 4x over 2 plus 5 over 2. Okay, and then we can simplify it like that. Okay, and then we can take that fraction across. Okay, and we did a couple of these when we were doing a straight line, okay, taking fractions from one side to the other. Okay, so when I've got a fraction over the other side, I need to turn that whole number into a fraction. Remember, 10 is just 10 divided by 1. Okay, then we've got a fraction minus a fraction, and we can do the kiss smile technique. Okay, so we can just cross multiply and then multiply the bottom two. Okay. (20 minus 5 over 2). X equals 15 over 2. And again, you can just move that 2 straight over. Okay, and it would be 15 divided by 4. Okay, or 15 divided by 2 times 2. Or you can write it out like that. Okay. Okay, if you write it out like that, then working through our rules of fraction. Okay. a fraction divided by another fraction, the rule is you flip the second fraction and then it becomes a multiple. Okay, so that x equals 15 over 2 multiplied by a half. X equals 15 over 4. Okay, now that looks quite convoluted, and it is quite convoluted. I'm just showing you that, okay, that there's different methods that we've walked through, okay, and we've done step by step. So different videos, I'll do different ways that sort of suit, but I'm just showing you that fractions can be written in different ways, and you just need to be careful with that, okay, especially when you're not given the bracket. Okay, so when there's no bracket around that expression, just make sure that you're aware that that expression has to stay whole until you get rid of that division. Okay, so let's have a wee go. Another one. Okay. Okay, and you get asked to solve for x. So you need to get rid of that division, and you need to sort of tidy up that bracket. Okay. Another way to write that out would be 4x plus 6 all over 3. Okay, so keep that bracket in just to keep yourself right. 10. Okay, that 3 has to come across. It becomes a multiple on the other side. Okay, so that expression on the left-hand side stays complete. Okay, and then it's a little bit more digestible once you get to this stage. Okay, just one of those things you need to look out for. One more sort of format can throw you. Okay. Anyone still copying? We're all good. One other sort of format that can throw you when you're sort of rearranging equations. Still a fraction involved. Okay. And then you throw a root in. That could be written, or you could write that as an expression at the top. Oh my God. 3x plus 5 all over 4. Okay. When you're looking at odd mass in this case, okay, in reverse, you've got lots of different aspects. Okay, but what we can do is move that plus over the first thing. Okay, so you might say, oh, there's an add there. I need to move that first. Because it's part of another thing, so it's because it's under that root and because it's part of that division as well, we can't just simply move that across. Okay, so we need to tidy everything away. We need to tidy all the noise away from it, okay, before we can move that term. Okay, so we need to take 4 across first. Okay, or we need to take that divide across first. Okay, and then do it in order from there. So 3x plus 5 becomes 6 multiplied by 4. Okay. Then we need to get rid of this root. Okay. Again, we're sort of digging, we're unraveling. Okay. We're unraveling to get to the core of that expression. Okay. So we need to take that root over. Okay. So that root's been applied to that expression. Take that over. When you move a root to the other side, it becomes squared. Okay. 24 squared, a big number. Okay, so you do that in your calculator. You wouldn't be expected to know that, I don't think. Okay, 3x plus 5, 576, that comes to. You can put that in your calculator to double check. Okay, and then you just tidy it up. Then if you put that in your calculator, you can't really simplify it any further, but if you put that in your calculator, you get that. Okay, it's just that order. Right, I'm going to give you a couple of questions. I'm going to give you 4 questions to do. Okay, let's say take about 15 minutes, maybe going through the questions, look over the examples I've given, go through the questions, just get it right in your head. Okay, so take 15 minutes doing that, then we'll take a 15-minute break off the back of that. Okay, so all in will be half an hour. Okay, so if we come back together and we call it, by the time I write this out, so we'll call it 10 to 8. Okay, we'll come back together at 10 to 8. Okay, so if you have a go at these questions. Okay, nice easy one to start. Pardon me. Okay, have we go at that? Okay, so take 15 minutes doing that, and then we'll take a 20-minute break. We'll come back together at 10 to 8. Okay, 10 to 8. There we go. Okay, nothing too surprising there. Just throw the answers at you. Okay, so x over 6, take a 6 across. Okay, it becomes a multiplication. Okay.
Sorry, do you think you could go over number 2? I didn't see any in the examples for number 2.
Yeah, of course.
Cheers.
Okay, so number 2, let's just take it to the side. 2, 3x. Okay, 2 over 3x. Okay. We can move either the 3 or the 2 first. Okay, this 3 bit where when you're doing multiply and divide and you're moving it across, okay, you can do one or the other. What I just wanted you to be aware of is how that could be written. Okay, you could also write that as 2x over 3 as a sort of full term like that. Okay, so you might see it written like that. So that X just goes onto that top line. That's really what I wanted you to be aware of. Okay, so that X can sit like that. Okay, but nothing changes. You take over that 3. Okay, and it just becomes 2x equals 10 multiplied by 3. Okay, so 2x equals 30. And then you're just left with having to take that 2 across, and it just becomes a divide.
Yeah, that's great. Thank you.
Okay. This one. And X. Okay. Any other ones? 3 or 4? We're quite happy with it. Okay. 4's a wee bit tougher. Okay, we take that 5 across. Okay, and then take that 2 across. And then you can sort of solve it from that point on. Okay. So we could write 4 as that. Okay, so you might see it written like that. Okay. So just by case of taking that 5 across. Oh. 5 across.
Don't you remove the root now?
Yep, I'm moving the root now.
Right, okay.
So
You did too early then.
where did I lose you? What point did you move the root, Sandra?
I moved it at the top where 2 times 5 is 10, and then I squared that. I squared the 10.
So you squared this point.
I,
Okay, so yeah, anything outside that root, okay, we need to deal with first.
right, I get you. Okay,
Okay, so we need to deal with that.
I see where I've gone wrong. Okay, thanks.
Okay, perfect.
2 outsides, yeah. I know where I went wrong.
No problem. Okay. Any more questions, guys? We okay? When you've got a chance, just have a wee look at that again and just go through it. Okay, so what I just want to go through is an equation with 2 fractions in it. Okay, and this will make sense when I do the example. The reason I want to bring this up is there's not a lot of examples in that document, that handout. Okay, but it's come up in the last 2 years' exams. Okay, this format of question. Okay, so before that, very, very, very rare. Okay, we hadn't seen it in a good few years, and then the last 2 years it's come up both times. Okay, so we'll go through it. So this is just equations with 2 fractions. Okay, equations. No, well, it's cutting out there. 2 fractions. Okay, so as I said, last couple of years it's come up. So what we want to do, whatever format it is, it'll give an equation with a sort of equal sign in the middle. We want to get the fractions together and then deal with them. And it will just be the same rules that we've discussed. So when we're adding them together, we do the smile kiss, multiply them together, etc. Okay, so example 1. solve for x. 2x over 5. Oh. Okay, so we've got that. 2x over 5 minus x over 2 equals 3. Okay, so it's the same sort of approach. What we need to deal with first is just these fractions. Now, we did this in unit 1, okay, and it's just a smile kiss. Okay. We get a single x term, and then we rearrange and we solve. Okay, so cross multiply and then multiply the two terms at the bottom. Okay, so 2x times 2, 4x minus 5x over 10, okay, equals 3. Got minus x, okay, minus 1x over 10 equals 3. Move that across. Okay. Now, here's where in an exam you'd want to leave x as the positive and get rid of that negative and move it to the other side. Okay. Essentially, what we've not written, okay, but what we know now is there, is that's that minus 1x. Okay, so it's multiplied minus 1x. We're taking away minus 1x and we're putting it to the other side. So we can divide 30, okay, by minus 1x, and that would leave us with a positive x. So we're removing it from the left-hand side. Okay. Effectively, we're just dividing it by 1x. Okay, so x, let's tidy up, it's minus 30. Okay, does that make sense? So we want to leave x as a positive in that case. So we're dealing with those fractions, we're using those rules that we looked at in unit 1. Okay, nothing changes there. It's just that wee bit of extra tidying up at the end. Okay. Okay. Again, we're just going to cross multiply and then multiply the two terms down the bottom. We'll end up with a single x term, and then we can rearrange. So we're solving for x. We've got, what was that? It was 30x plus 3x all over 18. Okay. Okay, we lost anyone. That 18 wants to be moved across. Okay, get to that point, you're doing well. Okay, you obviously want to simplify that down. So we're looking for any number that multiplies into both. Okay, in this case, we can divide both the top and the bottom by 3 there. Okay, and we're going to get 6 over 11. Okay, so down into its simplest form, that fraction in its simplest form. Okay, I did that quite quick, but let me know if I lose anyone. Okay. Now, wee bit of added complication is we've got fractions on two sides. Okay, and we just need to tidy it up a wee bit. Yes, we want all the x terms on one side, so we're going to solve for x. So we want all the x terms on the left-hand side. Okay, so we want to move this term over here, and then we solve like we have been. Okay, so that whole expression, that 3x over 4, is just an added on to the 2. Okay, so it's an addition, so we're moving that across and it just becomes a negative on the other side. Okay. Everyone comfortable with that? Okay, so we're moving that whole, that everything in that red box, we're moving at the same time. Okay, because it's all part of the same expression. So we're just moving that all over to the left-hand side. Okay. Then we've got something we're sort of familiar with, and we can do the kiss smile. Okay, so 4x minus 24x, we got over 4 times 8, which is 32. Okay. Minus 20x minus 32. Now, what I would say, okay, if you look at that, you could simplify that at this stage and make the next part a wee bit easier for yourself. I'm not going to, okay, but you could simplify that fraction at this stage and just tidy it up a wee bit. Okay, so I'm just going to move this 32 across because it's a nice easy sum anyway. Okay, it just becomes 64. Okay. And divided by a multiple, the whole thing becomes multiple. Okay, what goes into 64 and 20? Let's just divide them by 2, make it life a bit easier for ourselves. That simplifies further. Okay. Okay, if you've got a wee bit of a complex fraction, don't be scared to just make that step. Just divide it by 2 or divide it by something easy that's familiar with you, and then just do it again. Okay, so that could have been done in one jump. I couldn't see anything obvious, so just divided it by 2, and then I divided it by 2 again, just to get to that last simplification. Okay. Anything there? Okay. A wee cough on, that's all worry. Okay, so that's a couple of examples. I'll show you a past paper where it comes up. Now, I've not taken what past paper this comes from. We've just taken the question. Okay. But we'll find it. Okay, so this is a past paper question. Okay, so solve equation. Solve the following equation: 2x. In fact, I think this was last year or the year before. Okay. Okay, again, that's a wee bit different again. Okay. But we'll follow the same process. Okay, and it also gives you the line give answer in its simplest form. Okay. Question will give you that line. Okay, it's just simplify as far as we possibly can. Okay, so it's not asking you for anything we don't do anyway. Okay, so again, it's just working through that process. Now, Up until now, I've been moving the x's, all the x's onto the one side and keeping the sort of full numbers away from it. We can tidy up the left-hand side a wee bit more, okay? And tidy up those two fractions, so we're getting rid of them, okay, and allowing us to move those numbers across. Okay, so I'll do it that way first. Okay, so I'm going to solve the left-hand side, bringing it into one single expression, then move everything across, and then solve for x. Okay, so let's just do that. Okay, so I'm going to do a kiss smile, as we normally do. Okay. I'll leave me with that. Okay, this just puts it in a format that allows me to easily move different parts of it and break it down. Okay, so I can move that 18 across. Okay, and leave me with okay. Now we just have to get the terms on the right side of each other. Okay. So we just need to pull that 36 across and move that 15 over so it's on the right hand side. Okay, so essentially we want to move that 15 over there. And in the opposite direction, we want that 36x to come back over. Okay. So 12x stays where it is. That 36x is positive in the right hand side. So when we're doing an addition, okay, it's going to become a negative. Opposite to that, 15 is negative on the left hand side and becomes positive. Okay, so that becomes negative 24x. And negative 24 we want to move across. Okay, it's a multiple on the left hand side, so it becomes a division on the right hand side. The negative sign stays, okay, because it's a divide. Simplest possible, okay, so what number goes into 15 and what goes into 24? Okay, we can say the number 3 does, so we can divide top and bottom by 3. 5 over 8, okay. Just make sure that sign follows you all the way through. Okay.
Why is it you divide it by 3? Like the 15 and 24?
This one?
Yeah.
Okay, so we're just simplifying. So simplifying that fraction down into its simplest form. Okay, that just leaves it in the smallest possible number that we can have. Okay, so 3 is the lowest common factor for both of those terms. Okay, so 3
right,
goes
yeah.
into 15 and 3 goes into 24.
Yeah, that's fine. Cheers.
Okay, so when the question says in its simplest form, that's the step it's looking for you to do. Okay, that next step to make sure. So 5 and 8 don't share any common any common factors, so we can't simplify that down any further. Okay. So that is a past paper question. I thought I had questions for you to practice.
Is that for 4 points or 3 points?
Points, marks. Good question. Let's think. So I would say definitely 3.
Right, okay, thank you.
I would say 3, and then a good day you might get 4 for that. But I'd have to look at the marking scheme just to pick that up. All right. Okay, so the thing is, I don't think this pack gives you any examples of that. No, it doesn't. Okay, using fractions, but it has come up in the last few years. All right, so certainly have a wee look through those questions and just make sure you're comfortable. Okay, start right at question 1. Just make sure you're comfortable with moving things across. Okay, so that's page 12 and 13. Okay. I'll look out more of those fraction ones for us to do as a sort of group. Okay. I don't know why there's no examples in that document. Probably because they were so rare up until the last couple of years that we just hoped, we crossed our fingers they wouldn't come up. Okay.
But looking at L, 6n minus 3.5, wouldn't that be 3.5?
This one here.
Uh,
Yeah, I
or do you
suppose.
or do you leave that as a decimal?
So you could leave that as a decimal, and a lot of the past papers, remember that before Christmas we looked at the past paper and add a decimal in there. So we'll look at sort of strategies and how to approach those questions, because they will come up. I think actually a past paper question we do soon. Yeah, probably next week. Okay, we'll do a past paper question and it's got another decimal in it. Okay, so probably about time we start using them, but we can do it both ways. Okay, so we'll make sure that we know that what fraction makes what decimal. Okay, and we'll just make sure we're comfortable with that. So you're right, you could write that as 3.5, or you could write it as 3.5. Okay, but yeah, I won't cover that. Okay, so last thing I wanted to cover tonight, and we'll see how far we get. Maybe just introduce. Okay, it's something called inequalities. Okay, so the equations we've been working on up until this point, the left-hand side is always equal the right-hand side. Okay, but sometimes it's important in maths for us to communicate when a number has to be greater than, or has to be less than, or has to be not equal to something. Okay, there's different reasons for that to happen. If you think about a fairground, for instance, if you're at a fairground, you have to be over a certain height to ride on a ride. Okay, or you have to be, I don't know, that's probably the most obvious one. You need to be over certain, so they could write that as you have to be greater than this number to allow you to do this. Okay, so that's one example of when you can use this. Okay, but they're pretty common in maths where we have to communicate something's greater than or something's less than. Okay, but it's still going to be a variable. Okay, so we're still going to have letters in there. Okay, so that letter is just going to represent something. Okay, so inequalities. And the way that we treat inequalities is very similar to the way we treat equal sort of expressions as well. Okay, calculations. Okay, when the left-hand side equals the right-hand side, how we deal with it is pretty similar. There's only one special circumstance that we need to be aware of. Okay, and it's something, it's a really common one to trip you up. Okay, so the symbols that we're going to use, okay, is number is greater than another number. Okay, so you'd have something on the left-hand side of that arrow, and then you'd have something on the right-hand side. Okay, the number don't know what that's doing.